Good day. Let's just go through to chemical equilibrium. So under chemical equilibrium, I want us to talk about the Chatelier's principle, or how to explain using the Chatelier's principle. So let's say we're having the reaction here, A plus B, and then the reaction is reversible, then C plus D. So let's just see, this is 2A and then this is 2C. So this A is in gaseous form, and then this one is solid, and then this one is gas, also this one is gas. So remember, on a chemical equilibrium, a solid has no effect. So once we increase the concentration of a solid or we decrease, nothing is going to happen to the chemical equilibrium. So on this reaction, since we want to talk about the Chattelier's principle states that when the system in a closed system is disturbed, the system will reinstate the new equilibrium by opposing the disturbance. So, or by opposing whatever that happened. So now we want to disturb the system. So to disturb the system, that means we want to increase the concentration of the reaction. So what's going to happen? Let's say now we're increasing, or let's say A is added in the mixture. A is added in the mixture of this reaction. So now what's going to happen? Since A is added in the reaction, it means that we are increasing the concentration of A. So I want you to listen carefully here. We're increasing the concentration of A. So once we add or we remove, it means that we're talking about the concentration on that time. So it's only concentration that we can add and remove. So now we're adding A, it means that we're increasing the concentration of A. So now what's going to happen? Since we're increasing the concentration of A, so here we're going to use the point form to answer these questions. So since, let's say, point number 1, the concentration of A, let me use these brackets for concentration. So the concentration of A is increased. So since the concentration of A is increased, it means that now you are going to say the system, according to the Chattelier's principle, the system will react. The system will react to decrease the concentration. So let me use this bracket. The concentration of A. So that's the first point that we're going to say. The system will react to decrease the concentration of A. Since we're adding A, it means that the system should oppose or must oppose that disturbance. So it means that the system will oppose by decreasing that concentration of A. So since the concentration of A, or the system is decreasing the concentration of A, it means that the forward direction will be favored. So since this is our reverse direction, this is our forward direction, it means that the forward direction will be favored. So forward direction is favored. So this is what we must do, or we can see, we can cram if we can. So with the concentration, when you add on the reactants, since we are calling the reactants as a reverse, when you add on the reactants, the other side is going to be favored. When you add the products, it means that the other side will be favored. So when you add this side, the system is going to favor the other side. But when you remove, it's vice versa. When you remove that side, it means that the system is going to favor the same side. So here, since we are adding the concentration of A, it means that the system is going to favor the other side. So the other side is our forward reaction, and then the reactants is the reverse reaction, right? So since now the forward direction is favored, it means that the last point we are going to say more. Since this side is favored, it means that more C and D are produced. So since this side is favored, it means that more C and D are going to be produced according to the Chattelier's principle. So the first point we are going to say, the system will react to decrease the concentration of A. Since we are increasing the concentration that side, it means that the system should react to decrease the concentration of A. So point number 2, since we're adding the reactants, it means that the system is going to favor the product. So it means that forward direction will be favored. And then the last point, more C and D are going to be produced. So that's how we answer this question according to the Chattelier's principle. So now let's check when we decrease the concentration. So let's say now A is removed. A is removed. So here we're adding, now here we are removing. So removing, it means that we are decreasing the concentration of A. So let's say the concentration of A now is decreased. So since the concentration of A now is decreased, the first point, it means that the system will react to increase. Check, it's opposing. We decrease or we remove the concentration of A. It means that the system should react to increase that concentration of A. So the system will react to increase the concentration of A. So like I say, when you remove this side, it means that the system is going to favor the same side that you are removing something. So here we are removing A, it means that we are decreasing the concentration of A. It means that A is going to be favored here. So check it, where is A? A is in the reactants, it means that is our reverse reaction. So point number 2, now we're going to say reverse reaction. Reverse reaction is favored. So since reverse reaction is favored, it means that the last point, C and D are going to decrease now. So C and D will decrease. So since here we're talking about the disturbance, so we decrease the concentration of A. The system will react to increase the concentration of A. Once it does that, it means that it's favoring the reverse reaction. After favoring the reverse reaction, it means that the products are going to decrease. So our product is C and D. It means that our products are going to decrease according to the Chattelier's principle. So here we're adding we're increasing the concentration. Here we were decreasing the concentration, right? So on the other side, it's the same stuff. We increase the concentration, something is going to decrease according to the Chattelier's principle. So now let's talk about pressure. So before I forget, since we have three factors that are affecting the rate of reaction, right? So the first one, let me see, factors, I forgot to say that, factors affecting the rate of reaction, I mean the equilibrium, affecting the equilibrium, equilibrium. So the factors that are affecting the equilibrium, one is concentration, two is pressure, then three is temperature. So these three factors are affecting the chemical equilibrium. So here we have the catalyst, but the catalyst doesn't affect the chemical equilibrium. It only affects the rate. Let's be clear. Catalyst, it only affects the rate. It doesn't affect the equilibrium. So now let's talk about the pressure. What's going to happen when you increase the pressure or decrease the pressure on the system? So our reaction, it was 2A as a gas plus B as a solid, then the reversible reaction 2C as a gas plus D as a gas. So now what's going to happen here? Let's say we're increasing the pressure, or we are decreasing the volume of the container. So pressure, let's talk about pressure so that no one will be confused. So pressure is increased in the system. So when you increase pressure in the system, what's going to happen? When you increase pressure, it means that the system will favor the site with less number of molecules. Get that? So we're increasing the pressure now. So increasing the pressure, it means that the system will favor the side with less or lower, let me use low number of molecules. So since increasing pressure, it favors the site with a less number of molecules. After saying that, this is the first point that we're going to say. So after saying that, it means that now you must, okay, number of molecules of gas, let me be specific, because we're talking about gases. Pressure, it only affects the gases, and then concentration is gases and aqueous. So for pressure, it's only gases. So now let's check. After saying this point, the system will favor the site with less number of molecules of gas. After saying that, now you go back to the reaction. You count the number of molecules. Since this one is a solid, it means that it doesn't affect anything. So we are not going to count the solid, it's only gases. So let's check. This one is 2. It means that on the reactants we have 2 moles. Right? And then on the products, how many moles? It's 2 plus 1, which is 3 moles. So now let's check. On the reactants, it's only 2 moles. On the products, it's 3 moles. It means that now reverse reaction will be favored. So second point, reverse reaction is favored. So since reverse reaction is favored, it's favored. Why? Because it has less number of molecules. So since now it has less number of molecules, this site will be favored. So therefore, now we're going to say C and D are going to will decrease. They are going to decrease. Why decreasing? Because we are favoring this side. It means that we have to make sure that the reactance must increase so that at the end the system is going to be at equilibrium. Right. So the first point here with pressure, when we increase the pressure, the system is going to favor the side with less number of molecules. Point number one. Point number two, you check which side it has less number of molecules of gas. So we found out that on the reactants we have 2 moles, on the products we have 3 moles. It means that the reactants have less number of molecules. Then you go to your point now. Reverse reaction will be favored according to the number of moles that you found in the reaction. Reverse reaction will be favored. And then since reverse reaction is favored, it means that the products are going to decrease. So that's why we're saying C and D will decrease. But if we are decreasing the pressure or we're increasing the volume, sometimes they will talk about the volume according to Boyle's law. So since we are decreasing the pressure or by increasing the volume, it means that the system will favor the site with more number of molecules. That's what you're going to say. So, okay, let's just write it down. Now, pressure is decreased. Let's just say by writing is decreased. So since pressure is decreased, it means that the first point we are going to say the system will favor the side with more. We're decreasing the pressure, remember? So that means the side with more number of molecules of gases. So the system will favor the side with more number of molecules of gases. So when we check, we found out that the products, they have 3 moles, the reactants, they have 2 moles. So since here decreasing pressure, it will favor the side with a more number of molecules. It means that the one with 3 moles now is going to be favored. So which is what? The forward reaction. So now we're going to say forward reaction is favored. Forward reaction is favored. So by saying that, it means that since you are favoring forward direction, it means that now what's going to happen to the reactants now? So it means that A will decrease. So this is pressure. It means that when we decrease the pressure, first the system will favor the site with less number of molecules, number one. Number two, the forward direction will be favored. And then number three, A was going to decrease, just like that. So now let's say we're going to talk about the temperature. So by talking about the temperature, I didn't say anything about the condition. The condition is delta H is less than 0 or the heat is less than 0. So since the heat is less than 0, it means that on the temperature, the first point that you are going to say, you check the condition. The condition says the heat is less than 0. So since the heat is less than 0, it means that it's exothermic reaction, right? So the first point that you are going to say, you are going to say exothermic. When they increase the temperature, it means that you are going to say exothermic reaction is favored. Oh, sorry. Increasing the temperature, it means that endothermic reaction is favored. That was my mistake. Endothermic is favored because we are increasing the temperature. But when they decrease the temperature, you are going to say exothermic is favored. So before you say anything, that is the first point that I'm going to say with the temperature. So let me just write down. It's A, 2A gas plus B solid, the reversible reaction, 2C gas plus D gas. So the heat is less than 0. So now let's say temperature is increased. So since temperature is increased, the first point that we're going to see is once we increase the temperature, that is endothermic reaction. We don't negotiate. So endothermic reaction is favored. Before you say anything, endothermic reaction is favored. Now, after saying that point, now you go back to the reaction. That's where you're going to say, now since the heat is less than 0, and according to the Chattelier's principle, or not according to the Chattelier's principle, according to the reaction, increasing the temperature, it favors endothermic reaction. So now you come back here. According to the Chattelier's principle, endothermic reaction is favored, right? So since endothermic reaction is favored, now you check the heat is less than 0. Since the heat is less than 0, it means that the forward reaction is exothermic reaction. Why? Because the heat is less than 0. Less than 0, it means that it's exothermic, right? So now you are going to say, since the heat is less than 0, exothermic reaction let me say not exothermic reaction, sorry. We're going to say forward. I wanted to say forward reaction is exothermic. Why forward reaction is exothermic? Because the condition is given as less than 0. So once the condition is given as less than 0, forward reaction is exothermic reaction. So since forward reaction is exothermic reaction, but we are increasing the temperature, it means that the system is going to favor the reverse reaction. So now the reverse reaction is favored. So since the reverse reaction is favored, it means that, check what is the reverse reaction. That is our A. So it means that C and D are going to decrease now. So C and D will decrease, right? So heat less than 0, it means that forward reaction is exothermic reaction. So you check the condition before you say anything. So the condition is telling you that the forward reaction is exothermic reaction because it's less than 0. If it was greater than 0, it means that the forward reaction is going to be endothermic reaction. So it means that when we decrease the temperature, exothermic reaction is favored. So with the temperature, it's easy to collect marks. You listen, they're increasing the temperature. Before you say anything about the reaction, they are decreasing the temperature. it means that exothermic reaction is favored. They're increasing the temperature, it means that the endothermic reaction is favored. So then after saying that point, now you go back to the reaction, you check the condition. If the condition is less than 0, forward reaction is exothermic reaction. If the condition is greater than 0, it means that forward reaction is endothermic reaction. So that is point number 2. Point number 1, you don't check anything, you just go straight. They're increasing the temperature, endothermic reaction is favored. They're decreasing the temperature, exothermic reaction is favored. So for now, let's just cut it there.